All right, let's jump straight into this explainer and uncover what I like to call the hidden hero of the oil well. We're looking at a piece of equipment that's installed on day one, buried way down in the cellar, yet it literally holds everything together. I'm talking about the casing head. It's the ultimate foundation fitting, and honestly, once you understand how it works, your entire perspective on how a well is constructed is going to change completely. So I want you to imagine something for a second. Just picture hundreds of thousands of pounds of solid steel pipe literally hanging miles down into the earth. Now, on top of that, add up to 15,000 psi of highly volatile pressure just violently trying to escape to the surface. So what single part carries all that weight and holds back all that pressure? Go ahead, take a guess. Actually, scratch that. I'll tell you right now. It's definitely not the massive derrick, and it's not the drilling rig itself. Right, so if you look at any wellhead and just follow it down from the very top, you start with the Christmas tree that bolts to a casing spool. Then that spool bolts to another spool. During the drilling phase, you've got the massive blowout preventer, the BOP stack, bolted on top of the whole shebang. But if you keep following that path down, literally stripping away all those complex layers top to bottom, you eventually land right down in the cellar. And what do you find down there? Just one single, heavy flanged fitting sitting right on top of the very first string of casing. I seriously cannot emphasize this enough. Everything on a wellhead sits on this one single part. Every load, every high-pressure seal, literally every piece of surface equipment you see above ground is ultimately carried by this one heavy steel body. It is the absolute anchor of the entire operation. So what does this hunk of steel actually do? Well, the casing head performs three absolutely critical functions. First up, it provides a housing to physically hang the next casing string that goes down into the earth. Second, it allows the annulus, that empty space between the different casing strings, to be completely sealed off. And third, its top flange is the precise mounting face that the BOP stack and eventually the production Christmas tree bolt directly onto. So it hangs, it seals, and it mounts. Boom. That's the structural foundation for the rest of our analysis right there. Now, you might be wondering how it physically manages to hold that mind-boggling amount of weight without failing. Well, it all comes down to what we call slip-type hangers. Inside the casing head is this beautifully machined tapered bowl. When the next string of casing is lowered through the head, these wedge-shaped slip hangers drop right into that bowl. They completely surround the pipe, getting ready to support that entire hanging casing string. And what's really fascinating here is just the elegant physics at play. The bowl is tapered, right? So as that incredibly heavy string of casing hangs below, its weight pulls down on those wedge-shaped slips, meaning the heavier the string of casing gets, the tighter it wedges those slips into the bowl and the harder it grips the pipe. The string's own weight literally does the gripping for us. It's just a brilliant, self-reinforcing mechanical lock. This actually brings us to a core engineering mantra in the field: support first, seal second, using the load itself as the clamping force. Once the physical load of the pipe has clamped those slips tightly into place, only then is a pack-off seal energized above the hanger, and that is what closes off the annulus. You secure the massive physical load first, then you worry about the pressure seal. It's a foundational concept in the industry for sure. Slips, bridge plugs, casing hangers, they all use this exact same idea to function. Now, if you've ever looked closely at a casing head, you've probably noticed valves sticking out the sides. Those side outlets? Yeah. They aren't just there for decoration. They are absolutely crucial access points. In fact, they are your only access to the annulus behind that casing string. Engineers rely on these specific valves for the entire life of the well. We're talking using them to monitor annulus pressure, to bleed off dangerous trapped pressure, and to circulate our pump fluids during the cementing process. When an engineer reads the pressure on an annulus, they are getting that rating right there, straight off a casing head outlet. But here is where we get into some pretty severe operational hazards. Casing heads are actually rated in two distinct ways, and trust me, both matter. First, there's a hanging load capacity for the weight of the string beneath, and second, a working pressure rating. So just imagine for a second bolting a 10,000 psi BOT stock onto a casing head that is only rated for 5,000 psi. That is a critical and, frankly, terrifying mismatch. And this perfectly illustrates the golden rule of wellhead ratings. The stack is only as strong as its weakest flange. A casing head's working pressure rating absolutely must always match or exceed the BOP bolted above it. No exceptions. If you've got a 10,000 psi blowout preventer, your foundation casing head better be rated for 10,000 psi or more. Otherwise, your whole high-pressure safety system is just an illusion. Okay, I want to slow things down for just a moment here because we need to get deadly serious about the biggest hazard that catches people completely off guard out in the field. It's a phenomenon known as trapped annular pressure. And guys, it is a silent burst risk. The physics behind this are honestly terrifying. Fluid gets sealed in the annulus, again, that gap between the casing strings, with absolutely nowhere to go. Now, when the well starts producing hot oil and gas from deep underground, that trapped fluid heats up. And here is the crucial fact you need to remember. Liquid barely compresses. Because of this, even a modest temperature rise causes thermal expansion that produces a massive, massive pressure spike. That pressure can actually rise high enough to physically collapse the inner casing string or completely burst the outer one. It's exactly why those side outlets we just talked about are used to constantly monitor and bleed pressure. If there's one hard-hitting takeaway you get from this explainer today, make it this. Never, ever assume a sealed annulus is a safe annulus. To really cement just how critical this piece of equipment is, let's look at a brilliant analogy. Think of a massive skyscraper's concrete foundation slab, the one with heavy anchor bolts cast right into it. Everything built above ground is designed around that specific foundation, right? And absolutely nothing above it can be stronger than it. Well, the casing head is the exact same concept. It is quite literally the foundation slab for the entire wellhead stack. And here is the kicker that most people completely miss about a casing head. The actual drilling phase of a well, that might only take 60 days. But the production phase, the working life of the well, can last 40 to 60 years. Because the casing head is the foundation, it has to be specified on day one for the absolute highest pressure that well will ever see in its entire future. Why? Because you can't just easily swap it out later if things change. You can unbolt and change a blowout preventer. You can replace a Christmas tree. You can work over the well a dozen times. But replacing a casing head, that requires killing the well entirely and bringing out a literal cutting torch. It is a massive, incredibly expensive physical intervention because it's welded or threaded right onto that first string and buried in the cellar. Which really leaves us with this final number to reflect on: 60. 60 years. That is the potential lifespan of this one hidden piece of heavy steel. When you spec a casing head, you are making a decision you have to live with for over half a century. If you get the foundation wrong, well, you live with it for over half a century. It kind of makes you wonder, doesn't it? What other hidden, permanent foundations are we building our modern world upon today without even realizing it?